This presentation will cover some of the basics of troubleshooting semi-automatic equipment and the gas metal arc welding process. Remember, however, that each situation is unique and may differ from the procedures outlined here. In all cases of equipment malfunction, the equipment manufacturer's recommendation should be followed. Troubleshooting is to be performed by qualified personnel only. Be sure to pay particular attention to the precautionary information in the owner's manual. Looking for simple things first is the key to most troubleshooting. For example, a work connection on paint or rust will not carry welding current. Make sure contact is made on a clean metal surface. Incomplete connections are another simple reason for no welding arc. A volt-ohm meter can be used to make a quick check for open circuit voltage. First, drive roll pressure is released and the gun trigger depressed. When the voltage check indicates that there's no voltage at the gun, but the voltmeter at the power source shows 19 open circuit volts, a continuity check can be made. Be sure to turn the power source off. Check the meter for continuity. One of the meter leads is connected to the work, and the other lead to the negative output stud of the power source. The meter indicates continuity of the work connection. A second continuity check is made by connecting one of the meter leads to the drive roll housing and the other lead to the positive output stud. Again, the meter shows continuity. The third check of the secondary circuit is made between the drive roll housing and the contact tube of the gun. Remember that secondary cables are often intertwined with other welding cables. A complete secondary circuit and proper open circuit voltage are the key to creating a welding arc. A common reason for an erratic arc is a contact tube in poor condition. An erratic arc can also be caused by voltage drop in the secondary as a direct result of loose connections, welding cables that are too long or too small in diameter. Heat buildup indicates a problem area. The meter here indicates 14 arc volts at the contact tube, while the power source meter shows 19 load volts. Extremely long cables cause this voltage drop. Loose or worn drive rolls can also cause an erratic arc. Spatter can indicate high voltage or other process-related trouble. However, in this case, the power source is set for 19 open circuit volts, and the voltmeter indicates 13 load volts. This may indicate a single phasing condition. A qualified electrician should be called to check each of the 3 primary fuses. Primary power is shut off and the fuse removed. The continuity check shows that the fuse is open. The new fuse is checked before it's installed. Jumper links on the primary board and primary input lead should also be checked for proper installation. A qualified technician can be called to check contactor points on some power sources or other internal components which can cause single phasing. There are a variety of reasons for no wire feed. Assuming that pulling the trigger will not activate the drive rolls, gas solenoid, or power source contactor. One of the simplest things to check is the on-off switch on the wire feeder. The 115-volt AC receptacle used to power the feeder should also be checked. The protective circuit breaker should be checked and a VOM used to check AC voltage. After installing the 115-volt cord, check the other end of the cord for AC voltage. Then secure the cable to the rear of the feeder. The fuse that protects the internal components on the wire feeder is checked. Check the new fuse before it's installed. A blown fuse indicates internal problems. If a new fuse is immediately blown, a service technician should be contacted. Another reason for no wire feed relates to the gun trigger circuit. The gun trigger leads removed and connections made for continuity check. Pulling the trigger must show continuity to activate the feeder. A mechanical reason for no wire feed could be related to something as simple as loose or worn drive rolls, a severely plugged contact tube, or a restriction in the gun liner. A quick check can be made by releasing drive roll pressure, removing the nozzle and contact tube, and pulling on the wire. If the wire is very difficult to pull, the gun liner should be cleaned or replaced. Before removing the liner, the wire is rolled back onto the spool and secured. The gun is then removed from the drive roll housing. Compressed air can be used to clean the liner. Cleaning the liner during every change of wire is good preventative maintenance. To remove a bent or worn liner, the liner set screw is loosened. The outlet guides removed and the liner pulled from the gun assembly. In many cases, installing a new liner is a quick method of returning the gun to service. Extreme drag on the wire feed system, such as a plugged liner or excessive drive roll tension, can cause an overload on the feeder motor. The circuit breaker on the front of the feeder is designed to protect the motor. High ropey beads can be caused by improper parameters. In this case, the electrode was hooked to the negative terminal, resulting in straight polarity. The electrode and work lead are switched for reverse polarity connection. Materials 16 gauge and heavier are most often welded with reverse polarity for deeper penetration and good appearing beads. A sound like bacon frying and a flat appearing bead is a result of proper equipment hookup and welding parameters. Porosity is generally not caused by a faulty welding machine or wire feeder. Checking the gas distribution system in this case indicates the shielding gas was not turned on. Both insufficient and excessive shielding gas flow can cause porosity in the weld. Loose fittings or cuts in the hose can not only leak shielding gas out, but could also draw air in while welding, causing porosity. Damaged O-rings can also draw in air. Spatter accumulation in the nozzle can cause turbulent shielding gas flow patterns or a lack of gas coverage, which results in porosity. If no gas flows when the purge button is depressed, the problem could be a defective gas solenoid or something as simple as a pinched gas hose, which could cause porosity. Improper shielding gases or a high moisture content could also cause porosity. Rust and oil on the base metal is a common reason for porosity in the weld metal. Quality wire of the proper AWS classification must be used to produce porosity-free welds. Improper parameters such as high voltage can also cause porosity in the weld. While some spatter is normal with short-circuiting metal transfer, a common reason for excessive spatter is high voltage and high wire feed speed. Carbon dioxide is commonly used for short-circuiting metal transfer. However, a mixture of 75% argon and 25% carbon dioxide would decrease the spatter level. Wire composition will also affect spatter. For example, an ER70S3 wire can be used with carbon dioxide shielding gas. However, an ER70S6 wire would generally result in less spatter when using carbon dioxide gas. On machines equipped with slope adjustment or inductance control, the power source can be fine-tuned to help reduce spatter. In review, troubleshooting can generally be grouped into these three areas. An example of electrical is an open primary fuse. An example of mechanical would be a loose shielding gas fitting. A process example is spatter caused by improper parameters or improper shielding gas. Remember, identify the symptoms, check simple things first, and ask for qualified assistance when troubleshooting indicates internal problems.